Bremen, Germany, January 1943. The winter air clings to the concrete walls of a naval laboratory. Frost webs across the tall windows, muting the daylight into a dull gray. Inside, 3 German admirals stand silent before a table draped in canvas. Technicians, pale and exhausted, peel the cover away. Beneath it lies a strange metal box, compact, unfamiliar. Coils, waveguides, and a tiny rotating dish. The tag reads from a downed British aircraft. An engineer adjusts his spectacles and whispers, "Microwaves. Centimetric wavelengths." The admirals lean closer. One with the iron cross glinting on his chest frowns. "So, that's how they see us," he mutters. No one speaks further. The hum of equipment and the ticking of a wall clock fill the silence. They know what this means. Across the Atlantic, U-boats, once the hunters, are vanishing in the night, caught and destroyed before they even surface. What began as mystery now reveals its cause, a secret born from invisible waves. In 1939, when the first torpedoes cut through the cold waters of the North Atlantic, the German Kriegsmarine believed it had found its great equalizer. Germany's surface fleet was small, but its submarines, the U-boats, offered a silent, predatory strength that could starve Britain into submission. Every merchant convoy that sailed from Halifax or New York toward the British Isles became a target. The ocean turned into a chessboard of death, where periscopes rose like spears through the swells, and sonar pings echoed through steel hulls. By mid-1941, Admiral Karl Dönitz, commander of the U-boat arm, directed a fleet that seemed unstoppable. Wolfpack tactics, groups of submarines striking convoys at night on the surface, shredded Allied supply lines. In that year alone, over 1,200 Allied ships were sunk. The Atlantic, Dönitz declared, was our hunting ground. Yet beneath this confidence, the balance of power was already shifting. The Allies were learning, painfully, systematically, to fight back. The contest was no longer just between men, but between machines, mathematics, and the invisible spectrum of electromagnetic waves. The Royal Navy and Royal Air Force understood that no convoy could survive by escort alone. Aircraft, radar, code-breaking, and disciplined convoy tactics had to work as one. Bletchley Park's analysts were breaking portions of the German Enigma code, revealing U-boat positions hours or days before the enemy realized it. But at sea, technology still lagged. Early radar, long wavelength systems operating around 1.5 meters, was clumsy. It could detect a surfaced submarine only at short range and in clear weather. Against a small object on rough seas, it often failed entirely. At night or in fog, the ocean swallowed ships whole. For Dönitz's captains, this meant freedom. They surfaced under the cover of darkness, recharged batteries, attacked, and vanished. Their diesel engines rumbled like mechanical heartbeats across the waves. In the black void of the Atlantic night, Allied escorts searched blind. By 1942, the Battle of the Atlantic reached its bloodiest phase. U-boats prowled even the American coast. Operation Paukenschlag, or drumbeat, sinking tankers within sight of city lights. Flames lit the horizon off Cape Hatteras, and oil slicks burned across the surf. For a time, the war at sea seemed lost to the Allies. But the war in science was running on a different clock. In secret laboratories in Britain and the United States, physicists were condensing entire wavelengths of radio energy into a new scale, the centimetric band. The key was the cavity magnetron, a compact device generating powerful microwaves short enough to produce razor-sharp radar images. Where older radar blurred a U-boat into background noise, centimetric radar could pick it out even amid churning waves. It could be mounted on aircraft, compact, light, and devastatingly precise. The shift was invisible, but the consequences would be catastrophic for Dönitz's arm. By late 1942, the Allied Atlantic Command began integrating these new radar sets into long-range aircraft. The RAF Coastal Command's Wellingtons, Liberators, and Sunderland flying boats. Combined with improved radio direction finding, sonar, and depth charges, the once invincible U-boats began to die silently in deep water. Yet at the time, the Germans didn't understand how or why their submarines were being hunted so easily. Crews reported that Allied aircraft seemed to appear out of nowhere, even on moonless nights. No radio transmissions had betrayed them. No sonar pings had echoed, yet death descended from the clouds. Admiral Dönitz demanded answers. Intelligence officers speculated wildly. New radar? Improved HFDF? Luck? Nothing explained the pattern. Each report that reached Berlin was a page in a growing mystery. In U-boat pens from Lorient to Saint Nazaire, morale thinned. Captains spoke of phantom eyes, something watching them in the dark. By late 1942, losses were climbing sharply. The Allies had begun to reverse the tide, but few on either side yet realized that the real battle was now invisible, fought in frequencies measured in centimeters. That invisible war between wavelength and wave, between silence and signal, was about to define the fate of every man beneath the Atlantic, and at its heart stood a small, humming device that Germany had yet to see with its own eyes. By the closing months of 1942, a quiet revolution was underway across British airfields. In hangars lit by single bulbs, engineers worked through the night, bolting the new centimetric radar units, ASV Maquette 3rd, into the bellies of aircraft. These boxes, powered by the cavity magnetron, could detect the tiny silhouette of a submarine's conning tower from miles away, even through cloud or darkness. For the first time, Allied air crews could find the hunters before they struck. Yet there remained one crucial flaw. Seeing the U-boat didn't mean destroying it. When radar-guided aircraft closed in, the final seconds before attack were often lost in darkness. The pilot would lose visual contact and be forced to abort or guess. Many submarines escaped simply because the sea swallowed all light. That problem found its answer in another British invention, the Lee Light, named after squadron leader Humphrey de Vere Lee. Was a massive searchlight fitted beneath aircraft, synchronized with the radar system. The radar guided the approach. The light illuminated the target at the last moment. When switched on, it turned night into day, a white-blue beam blasting across the waves, freezing the startled U-boat crew in its glare. It was psychological warfare at its purest, for men who had believed themselves invisible under the moon. The sudden burst of light was blinding, apocalyptic. Within seconds, depth charges crashed into the sea, and the submarine, once predator, became prey. The first successful attack using the combined ASV Maquette 3 radar and Lee Light came in mid-1942, when a Wellington bomber of RAF Coastal Command destroyed U-502 in the Bay of Biscay. The news spread quietly through Allied ranks. No public announcement was made. The advantage was too precious to reveal. By early 1943, entire squadrons were equipped with the new system. Aircraft from bases in Iceland, Northern Ireland, and Cornwall began to patrol the mid-Atlantic gap, the so-called Black Pit that had long been beyond escort and air cover. Within weeks, reports of successful strikes multiplied. German listening stations intercepted Allied signals, but could not decode their meaning. Wehrdienst, the Kriegsmarine Signals Intelligence Branch, had no idea that centimetric radar even existed. The wavelengths were too short to be detected by their warning receivers, which were tuned only to the long-wave radars used earlier in the war. U-boat crews carried METOX detectors, small wooden boxes with rotating antennas designed to pick up Allied radar signals. For a few months, METOX gave them some warning, but by late 1942, crews noticed that even with METOX switched on, aircraft still appeared without notice. Some captains began to suspect that the device itself emitted detectable radiation, betraying their position. Panic and superstition crept in. Admiral Dönitz refused to abandon the Atlantic. To him, the sea lanes were Germany's last hope of strangling Britain's war economy. Even as losses mounted, he pushed for more aggressive patrols, more wolf packs, more courage. "The Atlantic is still our battlefield," he told his officers. "We will not yield it." But the battlefield had changed shape. The Allies had filled the night with unseen eyes. By the start of 1943, radar-equipped aircraft had closed the mid-Atlantic gap almost entirely. Convoy escorts carried improved sonar, ASDIC, Hedgehog mortars, and radio links that allowed rapid coordination with air patrols. Every new ship launched under the U.S. Liberty program replaced tonnage faster than the U-boats could destroy it. Meanwhile, in Berlin and Kiel, German scientists began collecting fragments of wrecked Allied aircraft. Searching for clues, They had heard rumors of a new radar, shorter in wavelength, far more precise. But no intact example had yet fallen into their hands. That would change soon. And with it, the entire understanding of why the Atlantic had turned against them. One cold January morning in 1943, in a hangar outside Bremen, a captured Allied radar set was uncrated and laid before a circle of German admirals. For the first time, they looked directly at the machine that had been hunting their submarines, and in that moment, theory became truth. Angle 1. The human dimension. Life beneath the Atlantic. The inside of a U-boat was a world apart. A steel capsule where air grew thick with diesel fumes, oil, and sweat. 40 men lived in silence beneath tons of crushing water. Every sound mattered. A creak, a propeller beat, the faint buzz of sonar. For months, these men were told they ruled the ocean. They were the gray wolves, striking unseen and vanishing before retaliation could reach them. But by 1943, the ocean had changed. Sudden death now came without warning. A distant hum, the faint roar of an unseen aircraft, and then explosions that tore through the hull. Many U-boats never even reached periscope depth before being destroyed. Survivors spoke of an invisible hunter, a ghost that found them even in the blackest nights. Letters recovered from lost submariners show fear cloaked in duty. One crewman wrote to his wife, "We surface only for air, and already they are above us. They see us through the clouds, through the dark. It is not war, it is haunting." The invisible war eroded morale faster than torpedoes could kill. Dunitz's men were brave, but courage could not fight what they could not see. When the captured radar was finally examined, the truth of that invisible presence would crush the last illusion of control. Angle 2. The tactical dimension. The changing game of convoys. The Battle of the Atlantic was not a single fight, but a vast and evolving system of tactics. By 1942, the Wolfpack approach had reached its peak. U-boats coordinated attacks through encrypted radio, converging on convoys to strike en masse. Allied escorts were overwhelmed by simultaneous torpedo runs and surface gunnery at night. But radar shifted the tactical equation entirely. Long-range aircraft, guided by centimetric radar, began patrolling ahead of convoys, sweeping the dark seas for periscopes and conning towers. What once required luck now became procedure. Faint radar echo on a cathode screen could mean a submarine 5 miles ahead. Within minutes, the aircraft would descend for the kill. At sea, escort commanders learned to trust those blips. Destroyers and corvettes adjusted formation, launching attacks based solely on radar and sonar fusion. Radar allowed convoys to sail in tighter formation at night, confident that aircraft or ships could detect any lurking threat. German tactics, once fluid and daring, became desperate. U-boats began operating submerged during the day and surfaced only at night to recharge batteries. But radar denied even that sanctuary. The very act of surfacing became a death sentence. By early 1943, convoys that once lost half their ships were crossing the Atlantic intact. The tactical dominance of the U-boat had ended before Dönitz realized it, and the Germans' inability to detect the radar's wavelength meant their boats were blind to their hunters. Each night became an experiment in survival, one whose outcome was decided long before the first depth charge fell. Angle 3. The technological dimension. The rise of centimetric radar technology had always shadowed strategy, but in this war it defined it. The British cavity magnetron, developed in 1940 at the University of Birmingham, was one of the most significant inventions of the entire conflict. It shrank radar from building-sized apparatuses into compact aircraft-mounted units. Traditional radar used meter-long wavelengths, adequate for spotting bombers but hopeless for detecting submarines. The magnetron produced microwaves at 10 centimeters or shorter, concentrating energy into tight, precise beams. The difference was revolutionary. Instead of vague echoes, centimetric radar produced crisp returns from even small metal objects against a rough sea. The first Allied system to exploit it, SV Makeda 3, transformed night operations. Aircraft could scan vast areas quickly, detecting U-boats that thought they were hidden. Unlike older radar, it was immune to German receivers like Metox or Naxos, which couldn't perceive such high frequencies. To German scientists, once they finally examined a captured set, the discovery was staggering. The components, magnetron cavities, waveguides, and tuning circuits, represented a level of miniaturization and precision that Germany had not yet achieved. Their own radar research, though advanced in theory, lagged in production and scale. This was more than an engineering triumph. It was a psychological one. The Allies had achieved invisibility through sight itself. In one surviving report, a German engineer remarked, "We did not believe it possible to generate such power from so small a device. It is the work of another world." The magnetron's success symbolized a broader truth. By 1943, the war's front line was no longer defined by territory, but by innovation. Every wavelength shortened meant another mile of ocean reclaimed. Each human fear, tactical failure, and technological leap intertwined to produce a single, terrible realization. The U-boat was no longer the hunter. That realization would become undeniable in the months ahead, when the Germans for the first time saw what their enemy had built. Angle 4, enemy intelligence, the moment of realization. For months, German naval intelligence had struggled to explain the U-boat catastrophe. Signals monitoring, field reports, and crew testimonies contradicted one another. Dönitz's analysts at Carnival and Berlin searched for patterns, weather conditions, convoy routes, moonlight phases, anything that could justify why submarines were being ambushed with such precision. In late 1942, fragments from wrecked Allied aircraft began arriving at laboratories in Bremen and Rechlin. Engineers carefully examined each twisted metal panel, each wire and circuit, hoping for answers. Yet what they found only deepened the confusion. Pieces of unfamiliar equipment, compact, finely machined, operating on frequencies their instruments couldn't even measure. Then, in January 1943, fortune, or fate, delivered clarity. A British aircraft equipped with the new radar crashed intact off the French coast near Brest. German recovery teams secured the radar set, nearly undamaged. It was transported to a naval research facility near Bremen. What they uncrated that winter morning changed the entire perception of the Atlantic War. German engineers connected the device to test instruments, scanning its frequency output. The readings were so short they stunned the observers. Centimetric wavelengths, orders of magnitude smaller than any radar Germany had deployed. When Admiral Dönitz and his staff were shown the demonstration, the silence in the room was absolute. The British radar's rotating antenna produced sharp echoes from a small metal target across the hall. In that instant they understood. Every U-boat lost at night, every inexplicable air attack, every phantom detection, all explained by these invisible centimetric eyes. Germany's entire detection network, METOX, Naxos, FUMB, was useless. Their receivers couldn't even see this radar signals. A report sent to Dönitz's headquarters stated plainly, "The English possess a form of radar beyond our present technical means. It renders the Atlantic unsafe for surface operation." The shock rippled through the Kriegsmarine. Years of doctrine built on stealth had collapsed in a single revelation. Engineers were ordered to design countermeasures immediately, but time and materials were scarce. While laboratories in Germany raced to catch up, U-boats continued to vanish beneath the waves. For Dönitz, the realization was personal. His fleet, once his pride, was being dismantled not by courage or strategy, but by science. Angle 5, moral and strategic dimension. The cost of technological superiority. The discovery of the captured radar didn't just expose a technological gap. It forced both sides to confront the moral cost of progress. For the Allies, centimetric radar symbolized salvation. It ended the nightmare of supply starvation, kept Britain alive, and opened the path for D-Day preparations. But for every technological triumph came a human toll. Thousands of young German sailors trapped inside burning submarines, the sea claiming them without trace. To the Allied air crews, those attacks were victories necessary for survival. To the men below, they were moments of helpless terror. The ocean became a graveyard of steel, marked only by oil slicks and drifting wreckage. The radar itself, a silent, impartial machine, made no distinction. It simply revealed, It reduced warfare to a contest of frequencies, measurements, and circuits, where the side with the shorter wavelength dictated who lived and who died. Strategically, this breakthrough signaled the death of the old romantic image of naval combat. Heroic chases and periscope duels gave way to mathematics and electromagnetic energy. Commanders no longer fought each other directly. Their machines did. Inside Germany, moral fatigue spread among U-boat crews. They sailed knowing they were being hunted by something they could not counter. The few who survived spoke of feeling blind among ghosts. For the Allies, the success of radar validated years of secrecy, research, and sacrifice. The cavity magnetron, once a small copper block on a lab bench, had become the most decisive weapon in the Atlantic. This was the new face of war. Not brute strength, but intellect. Not courage alone, but calculation. The moral weight shifted from the battlefield to the laboratory. Scientists became the new soldiers, their discoveries measured in lives saved or lost. By spring 1943, this invisible revolution reached its breaking point. The Battle of the Atlantic was entering its most decisive phase, and the revelation in Bremen had shown the Germans that their mastery of the sea was over, yet they would not yield quietly. The following months would bring the bloodiest period the Atlantic had ever seen, a clash between desperation and inevitability, as the U-boat fleet fought to survive against an enemy that could see in the dark. The winter of 1943 bled into spring, with an eerie stillness across the North Atlantic. Convoys continued to move. Blacked-out ships crawling through waves, escorted by destroyers and long-range aircraft. But something fundamental had changed. The hunters had become the hunted. From the air, the ocean was alive with motion invisible to the naked eye. Inside RAF Coastal Command control rooms, green radar screens glowed in the dim light. Blips flickered, faint returns that meant steel hulls, periscopes, or snorkels. Each pulse revealed an enemy position miles away. By March, aircraft equipped with ASV Mako 3 radar and Lee lights had become a permanent presence along the convoy routes. The U-boat fleet, once capable of operating with impunity, now suffered losses on a scale the Kriegsmarine had never experienced. On March 5, 1943, convoy SC-121 was attacked northeast of Newfoundland. Donitz committed over 40 U-boats to the engagement. Initially, they scored heavy hits. 13 Allied ships were sunk. But then radar turned the tide. Long-range B-24 Liberators from Iceland, guided by centimetric radar, found and destroyed 7 submarines in 2 days. The air crews never saw their targets until the final seconds. The radar guided every move. In the U-boat command bunker at Carnival, the reports arrived one after another. Positions lost, boats overdue, crews missing. For the first time, Donitz realized that numerical superiority no longer guaranteed success. The Allies were fighting a new kind of war, one of data, electronics, and coordination. The integration of radar, sonar, ultra-intelligence, and air power created what some historians would later call the first networked battlefield. In London, the Admiralty's tracking rooms resembled the command centers of a future war. Each U-boat sighting, each radar contact, each Enigma intercept fed into a constantly updating map. Convoys were rerouted dynamically, air patrols redirected in minutes. The ocean, once the U-boat's sanctuary, had become a grid under constant surveillance. Meanwhile, the U-boat crews were unraveling. To surface was to risk death. Even diving no longer ensured safety. Allied sonar and depth charge tactics had grown precise, relentless. Crews described endless hours of silence underwater, air growing foul, men collapsing from exhaustion, before the inevitable series of explosions above. In April 1943, Donitz launched another massive offensive. Over 60 submarines deployed to intercept convoy ONS-5, bound from Britain to Halifax. It was to be his statement of defiance, his attempt to regain the initiative. For several days, the Wolfpack struck ferociously, sinking 13 Allied ships. But then the counterattack came. Night fell over the North Atlantic, black as ink. Radar-equipped escorts detected surfacing submarines miles away. Aircraft guided in by centimetric radar dropped flares and depth charges in rapid succession. U-boat after U-boat vanished beneath plumes of boiling water. By dawn on May 6th, the convoy was still afloat, battered but intact. The sea around it, however, was littered with debris and oil. Over the next 48 hours, 6 U-boats were destroyed outright. Others limped home, damaged and demoralized. This was the beginning of what naval historians would call Black May. In that single month, the German Navy lost 41 U-boats, 1/4 of its operational force. Thousands of trained submariners disappeared beneath the waves, leaving no survivors, no graves. For every merchant ship sunk, nearly 2 U-boats were destroyed in return. The numbers alone told the story. 41 U-boats lost. Over 1,600 men dead, Allied shipping losses falling to their lowest since 1940. The Atlantic, once Germany's lifeline of power projection, had turned into its graveyard. At the tactical level, the effect was instantaneous. U-boat commanders began refusing to attack large convoys. Reports from patrol areas revealed growing reluctance to engage. One captain wrote bitterly in his log, "We are no longer the hunters. We are the hunted beasts." The strategic consequence was even greater. The Allies, now secure in their sea lanes, could begin the vast buildup for the liberation of Europe. Fuel, tanks, and men could cross the Atlantic without crippling loss. The foundation for Operation Overlord, D-Day, was being laid in those same convoys that radar had saved. But for Dönitz, it was an unthinkable defeat. He had built his reputation on the silent power of the U-boat arm, Germany's weapon of endurance and stealth. Now, within a few short months, that arm was broken not by superior numbers, but by an invisible invention small enough to fit in a bomber's nose. At his headquarters, Dönitz received one final devastating report. Of the last 10 boats dispatched, none have returned. He stared at the line for a long time, the paper trembling slightly in his hand. Around him, the walls of his command room seemed to close in. The invisible wave, centimetric radar, had changed the physics of war itself. The revelation in Bremen months earlier had been shocking. But now, in the spring storms of 1943, its meaning was no longer theoretical. It was written in wreckage and in blood. And as May drew to a close, Dönitz faced the decision he had hoped never to make. The reports on Dönitz's desk no longer read like combat summaries. They read like obituaries. One after another, the signals from U-boats ceased mid-transmission. No distress calls, no survivors, only silence. In May 1943, Admiral Karl Dönitz gathered his senior staff in the underground command bunker at Carnival. The walls, lined with map panels and strings of convoy markers, glowed under dim red lamps. The mood was suffocating. Dönitz stood rigid, his jaw set. "Gentlemen," he began, "we are losing the war in the Atlantic." No one replied. He continued, voice low but heavy with anger. "The British are finding our boats at night in fog, through cloud. There is something new, something unseen." He was right. The fragment recovered from the downed British bomber months earlier had revealed the secret. A compact magnetron-based radar working on centimetric wavelengths, ASV Mackay III. It rendered the ocean transparent. No U-boat could surface without detection. The German scientists at the Funkmessgerät radar division had tried to replicate it. They worked feverishly through the winter and spring, building prototypes of Naxos and Metox detectors to sense Allied radar emissions. But it was already too late. The Allies had leapt ahead technologically, and their use of microwave frequencies made the early German warning sets almost useless. The men around Dönitz knew what that meant. For the first time, the oceans themselves had turned against them. In one grim gesture, Dönitz ordered the suspension of all U-boat operations in the North Atlantic. "We must withdraw," he said, the words tasting like defeat. The order went out on May 24, 1943, the day that symbolically ended the Battle of the Atlantic as a contest of equals. But behind the tactical failure lay something deeper, a scientific revolution that had quietly reshaped the entire Allied war effort. While the U-boats retreated, inside the laboratories of Britain's Telecommunications Research Establishment, TRE, physicists and engineers were already planning the next generation of radar sets. The magnetron, the heart of the centimetric radar, had made possible airborne radar compact enough to fit in small bombers and night fighters. One of the engineers, Sir Edward Taffy Bowen, later described those months as the turning point of invisible war. The magnetron, once considered an obscure research curiosity, had become the core of a global system, from bomb aiming to submarine detection to meteorology. Dönitz's staff could sense it too. In their reports, the tone shifted from confidence to resignation. One analyst noted, "We face an enemy that sees without light, hears without sound, and strikes without warning." The U-boat fleet, the pride of German naval strategy, was now obsolete. And yet, Dönitz refused to surrender the idea of technological redemption. He redirected his scientists toward a desperate series of countermeasures: radar-absorbing coatings for periscopes, snorkel systems to reduce surface time, and experimental acoustic torpedoes to offset the Allies' advantage. But these were palliative measures, patches on a sinking empire. None could reverse the radar revolution. In the following months, as the Allies pressed their advantage, U-boat losses stabilized, but never reversed. Each new countermeasure introduced by Germany was quickly neutralized by Allied adaptation. The information war had accelerated beyond industrial pace. It had entered the age of electronics. Meanwhile, inside British intelligence circles, the success was recognized not as luck, but as the fruit of cooperation. The Tizard mission of 1940, which had sent British scientists and a magnetron design to the United States, had created a joint scientific empire. By 1943, thousands of engineers across Britain, Canada, and America were producing radar sets by the thousands, standardized, miniaturized, and distributed to every front. What radar had done to the Battle of the Atlantic would soon be repeated in the air war over Europe and the Pacific. Back in Germany, the captured British radar components were displayed like relics in the research facilities of Berlin and Kiel. Engineers examined the polished cavities of the magnetron, their faces lit with a mixture of awe and despair. They realized that their own radar technology, based on meter-length waves, was years behind. One scientist reportedly murmured, "This is not a device. It is a revolution in physics." The Kriegsmarine tried to adapt, introducing snorkel breathing masts and even researching stealth coatings. But the psychological blow was irreparable. Crews knew that the sea above them was no longer blind. Every time a plane's searchlight cut through the fog, it confirmed the truth. They were being hunted by a machine that never slept. In Allied command rooms, morale was electric. Airmen who once flew endless empty patrols now returned with confirmed kills. Convoy commanders spoke of seeing ghosts, radar blips appearing out of nothing, guiding them toward invisible enemies. To historians, May 1943 became more than just a military turning point. It was the first time in human history that information defeated force. The Battle of the Atlantic, which had raged for nearly 4 years, was decided not by bigger guns or more ships, but by a scientific principle that knowledge, transmitted as electromagnetic waves, could rewrite the rules of war. As the U-boats withdrew to the Bay of Biscay and the Arctic routes, Dönitz penned a final note to his remaining captains. "We fight on, not for victory, but for honor. The sea is no longer ours, but we remain its last defenders." By the summer of 1943, the Great Atlantic Blockade had effectively collapsed. Allied convoys flowed freely, supplying Britain and building the invasion forces for D-Day. Radar had ensured that the logistical artery of the entire Allied war effort would remain intact. The ocean, once ruled by silent hunters, now belonged to invisible eyes. And as one historian later wrote, "The Battle of the Atlantic was won not in the depths of the sea, but in the laboratories of Britain. When the order came to suspend Atlantic operations, it was not read aloud over radio. It arrived quietly, encoded in the daily transmission from Dönitz's headquarters. Each U-boat commander deciphered the message in silence. Some, drifting on the gray expanse of the mid-Atlantic, folded the paper and stared into the waves. The war that had defined their youth, the war of stealth and supremacy, was finished. From June 1943 onward, the number of active U-boats at sea fell sharply. Allied aircraft dominated the Bay of Biscay. bombing the submarine pens at Lorient, Saint-Nazaire, and La Rochelle day and night. The Kriegsmarine responded with heavier anti-aircraft armament and experimental radar warning devices, but none altered the outcome. The Allies could see first, and in modern warfare, that meant they could strike first. Inside Germany, the atmosphere within the U-Bootwaffe turned somber. Dönitz, promoted to commander-in-chief of the Navy, visited shipyards in Kiel and Hamburg where half-built submarines lay in dry dock. Engineers spoke of a new design, the Type WWII electroboot, capable of sustained underwater endurance. It was a vision of the future, a submarine designed for the age of radar. But the future would come too late. Production delays, bombing raids, and material shortages crippled the program. Only a handful of Type WWIIs ever reached the water before Germany's surrender. Meanwhile, Allied convoys began to cross the Atlantic in unprecedented safety. Supply ships carried tanks, aircraft, and millions of tons of munitions from American ports to Britain. For the first time since 1939, the Atlantic felt secure. The unseen war was ending, not with ceremony, but with exhaustion. By late 1943, Dönitz's headquarters reported U-boat losses exceeding 70%. Crews once considered the elite of the German Navy now faced the lowest survival rate of any service branch. In total, nearly 28,000 submariners perished, a casualty figure unmatched by any other force in the war. For the families left behind, there were no graves, only names engraved on memorial walls. The sea had claimed its own. Among the Allied air crews, the mood was a mixture of triumph and fatigue. Men who had once flown endless, futile patrols now returned with tangible victories. Yet even they recognized the horror of their success. Pilots recalled watching oil slicks expand across the surface, knowing hundreds of lives had just vanished below. The introduction of centimetric radar had reshaped more than tactics. It had redrawn the moral boundaries of war. Combat no longer depended on visibility, courage, or even proximity. It depended on circuitry and physics, on the ability to perceive what the enemy could not. At RAF stations across Britain, scientists who had once worked in secret now saw their inventions deployed on every front. The magnetron's miniature copper chambers, once guarded under lock and key, were being mass-produced in American factories by the thousands. Engineers like Sir John Randall and Harry Boot, who had first built it in a Birmingham basement laboratory in 1940, now watched it change the world. Their work had saved Britain, secured the Atlantic, and ensured that the tide of war would never again favor Nazi Germany. In the weeks following Black May, Dönitz authorized the creation of Flakboot, heavily armed anti-aircraft U-boats meant to lure Allied aircraft into attack. It was a desperate measure, and it failed. The radar-equipped planes kept their distance, attacking from beyond visual range with homing rockets and depth charges. The U-boat crews called them the ghosts of the sky. Each encounter confirmed the same truth the captured radar had revealed months earlier. The Allies possessed not merely new weapons, but new perception. They could see through darkness, fog, and cloud. Elements that once shielded the hunter had now turned into his tomb. The once mighty wolf packs dissolved into scattered remnants, operating closer to Europe's coastlines or in Arctic convoys. Their days of dominance were over. Yet even as defeat set in, Dönitz maintained the illusion of purpose. "We fight not for victory," he told his men, "but for duty." The Battle of the Atlantic had ended as quietly as it began, in the monotone pulse of a radar screen, the silent sweep that revealed everything and left nothing hidden. The Allies, now in full control of the sea lanes, turned their focus toward the next great operation, the liberation of Europe. And radar would once again lead the way, guiding bombers, ships, and invasion fleets through the storms of the coming year. The invisible war had changed form, but not ended. When the last U-boats withdrew from the mid-Atlantic, the war at sea did not end. It evolved. What radar had done for survival now began to shape strategy on a global scale. By late 1944, centimetric radar was everywhere, mounted on destroyers, escort carriers, night fighters, and even the landing craft that would carry Allied troops onto the beaches of Normandy. It had become the unseen commander of the Allied war effort, a silent director orchestrating the choreography of invasion fleets and bombing raids. During the Normandy landings on June 6, 1944, radar controlled not just detection but coordination. Allied ships guided their formations through darkness and storm, using radar navigation beacons. The same technology that had once exposed U-boats now guided thousands of vessels safely to the French coast. From that moment onward, warfare would never again rely on the eye alone. Germany tried to respond, but its scientists were stretched thin. Under relentless Allied bombing, radar laboratories in Berlin, Hamburg, and Rechlin struggled to continue work. Some breakthroughs did emerge. The Würzburg and Freya radar systems, the airborne Liechtenstein sets for night fighters, but they could not match Allied production or miniaturization. The magnetron remained a mystery Germany could not replicate in time. The irony was bitter. Only a few years earlier, German physics had been the envy of the world. Now it was chasing a revolution that had already moved on. In the winter of 1944, a small number of advanced U-boats equipped with snorkels attempted to re-enter the Atlantic. They could remain submerged longer, evading radar detection, but they were too few and too late. Allied radar, now integrated with Lee lights and HFDF, high-frequency direction finding, sealed the fate of any submarine daring to surface. When Germany finally surrendered in May 1945, Allied technical intelligence units immediately began seizing radar research facilities across Europe. Operation Surgeon and Operation Paperclip targeted not only rocket scientists, but radar engineers. The post-war world wanted their knowledge and feared their absence. British and American teams recovered, surviving documents from the German Funkmaskerade program and the captured British radar sets still preserved in laboratories. They found meticulous German notes describing their disbelief upon discovering the magnetron. One report from 1943 read simply, "The English device exceeds all known theoretical limits. We can detect it but not yet understand it." That single admission summarized the entire technological arc of the Atlantic War. In the years that followed, the magnetron and its radar descendants escaped the confines of military secrecy. The very principles that had once located submarines now powered civilian aviation, meteorology, and air traffic control. Radar towers rose across airports, guiding commercial aircraft through fog and storm. The same fog that once shielded U-boats from the sky. Even more unexpectedly, the magnetron became the heart of a peacetime invention few could have imagined during war, the microwave oven. In 1946, an engineer named Percy Spencer, working at Raytheon, noticed a candy bar melting in his pocket while standing near an active magnetron. From this accident came one of the century's most transformative household technologies. Thus, a weapon born in secrecy to hunt submarines became a tool for everyday life, a strange redemption born of destruction. But within naval circles, the memory of the radar war never faded. The Battle of the Atlantic became the textbook case of technological asymmetry, proof that innovation, not manpower, could decide the fate of nations. Historians later calculated that centimetric radar shortened the war by at least a year, saving millions of tons of shipping and untold lives. Yet even in victory, it raised questions that echoed into the Cold War. If unseen machines could determine life and death, what place remained for the human element in warfare? By 1945, the new era of electronic battle had begun. Radar networks stretched from Britain to Alaska, forming the early warning systems that would evolve into NORAD. Submarines, once masters of invisibility, would themselves be hunted by sonar and tracked by satellites. The invisible domain, electromagnetic space, had become humanity's new battlefield. For those who survived the Atlantic, the sound of radar's steady sweep became inseparable from memory. It was the heartbeat of an age that had learned to see in darkness, and never again trusted the dark. The war was over, but the radar's hum would never fade. Its echo would guide humanity into the nuclear age, the space age, and eventually, the digital world, all born from one moment in 1943, when German admirals examined a captured radar set and finally understood why their U-boats were vanishing. And that understanding changed everything. The Battle of the Atlantic ended not with the roar of guns, but with silence, the silence of understanding. In that winter of 1943, when German admirals leaned over a captured British radar set and watched its rotating beams sweep across a laboratory wall, they were witnessing more than defeat. They were witnessing the dawn of a new kind of warfare, one fought not in strength, but in perception. For centuries, the ocean had been a world of mystery, a place where courage and cunning decided fate, but radar stripped the sea of its secrets. It transformed the Atlantic from a battlefield of shadows into a measured, illuminated grid, a domain where machines saw what men could not. That single realization, that to see first is to survive, redefined every military doctrine that followed. It shaped the Cold War, the nuclear standoff, and the satellite age. It even shaped our daily lives, as the magnetron's hum found its way into kitchens, airports, and the digital sensors that guide aircraft through the skies today. In every radar screen sweeping arc lies the legacy of those years, the unseen war that taught humanity the value and peril of invisible power. It is the quiet intersection of fear and innovation, of destruction and discovery. The German admirals who stood before that captured machine could not have known how deeply it would change the world. They saw only defeat, the unraveling of a fleet, a doctrine, a dream. But history would remember that moment differently, not as the fall of the U-boat, but as the birth of the information age. From that laboratory in Bremen to the satellites orbiting Earth today, the principle remains the same. The quest to see beyond the horizon, to master the unseen. The radar's pulse still echoes through our world, calm, methodical, eternal, a reminder that every light we cast into darkness changes both what we see and who we are.